An interesting stat I like to throw out is that for an electric vehicle charger, you've got level one, level two, level three, level two and level three, or what are more common. Level two is a 7 kW charger. A level three DC fast charger is up to 350 kilowatts. That is
Right.
as much power as, depending on the home, over 100 homes. So if you think about a charging bank of 10 DC fast chargers, which we need on every interstate, every quarter, and every town to enable electrification, we're adding hundreds of the community-sized loads all over our grid, and the infrastructure is simply not able to support that. And so the way that I think about our role in that and microgrids is utilities, their technology hasn't changed fundamentally in 100 years. And what I mean by that is centralized generation, synchronous spinning machines, transmission, distribution. And it's
Right.
all radials from centralized generation and out. And so when you have an issue like capacity out at the end of the line, you have to go back and fix it all the way back to the substation or even to the transmission level, or sometimes all the way back to the generation level. And it
Right.
is incredibly expensive. But
Yeah.
now we have inverter and battery-based technologies. Really, I'd say, in the last 10 years, but really in the last like 5 years of becoming widely commercially accepted and technologically proven. It's not science projects anymore. It's real vetted products that can solve these issues for utilities in new ways. If you have a distribution line that is unreliable, instead of having to rebuild 10 miles of distribution line at over $1 million per mile, utility can now put in a battery at that critical customer at the end and solve that reliability issue for a fraction of the cost.